we talk about GeoSmart, the way I look at it is we had several speakers talk about location. The way I look at that is we're actually talking about very accurate location, not just any location, because location can change and the concept of location can be very vague, it can be abstract, because the entire planet can be location. Or it could be a location called, in the United States, we say New England. It's a bunch of states that come together and they're forming a New England. So the concept of location has become very precise, and it can be as precise as this building, or it can be as precise as my XYZ where I am standing. So the way I look at it is we are talking about precision location that's now coming from various sensors. Obviously, satellite imagery is one of those sources, and as Miladin was talking about, we have been collecting sub-meter imagery which talks about location of the planet that goes back to 2000. So when we talk about location, there are several sensors that are collecting this data. When you look at the terrestrial LiDARs, the FARO systems we saw today, the beautiful BIM models we saw from Bentley, or the GIS maps you see from Esri, the underlying concept is you are getting location from multiple sensors. So the one that keeps me up at night is the accuracy of the location these sensors bring to the table. So for example, if you have a smartphone, these smartphones 5 years ago, their positional accuracy was around 10 meters. That means if I took a picture of this screen today, and then I come back tomorrow and took a picture of the same screen, it could be actually 20 meters off in terms of cumulative positional error. So when we talk about location, I think what we're talking about is very precise location that's somehow matched up between various sources of location. And I don't see any of my colleagues from United Nations, but Mark Reichhardt from OGC is here. One of our favorite saying in UN GGIM is, everything happens somewhere at some time. So we now talked about location, now we're going to talk about the time aspect of it. Miladin is absolutely right. DigitalGlobe, our data goes to 2000. We have Landsat actually going back to 1972. The difference is, when you talk about Landsat, early years of Landsat, they were collecting imagery at 80 to 150 meter resolution. Now they're at around 30 meter resolution, where when you look at commercial companies like DigitalGlobe, we have been collecting sub-meter resolution since 2000. Now the latest generation of satellites, we are collecting every 50 centimeter piece of the entire globe. We have the data. Not only it's accurate in X, Y, but also Z. We'll talk about more about that. And then when we design these satellites, one of the things we do is we design them with a life of 10 to 12 years. We are launching a bird sometime later this year. So when you talk about geospatial technologies, just satellite remote sensing, if you add 12 years to 2016, we're already talking about data continuity well past 2027. And now, I think it was Dr. Mohan Reddy or someone else was talking about the number of devices we're going to have by 2020. The smartphones, they're getting more accurate. So you have 30 billion devices, if I may, Internet of Things. This is just phones, and there are Internet of Things that are going to give this location that will start providing this precision location of the entire thing that are happening on the planet on a much larger scale, I'm talking global scale, and at a lot more frequency we haven't seen before. If you have seen the latest press release from DigitalGlobe, we are partnering with one of our customers to launch a constellation of small sats. And in some locations, once we have the full constellation up and going, when you take our 5 birds we'll have by then, plus these new constellation of small sats, we can come back multiple times in a given day, something like every half an hour. So in terms of having the data, that's not the issue anymore. Between the smartphones, between the Internet of Things, between the satellite imagery, as well as these aerial sensors, UAVs, the location data is here. As Miladin said, data is just data. That's not what we're talking about. So third aspect of this location information is what I call context. Everything happens somewhere, sometime. We live in an interconnected world. We know that not only because of the economy, something is happening in the United States is affecting economy elsewhere. It's also some of the things that happen in the oceans or happen in the land. So it took 2 years for the debris from Japan's tsunami actually to reach the west coast of the United States. So all the debris started piling up. So whatever happens somewhere in the globe, it will manifest in terms of context. The context can be local, it could be regional, or it could be global. Or a different way of looking at the context is it could be at a micro scale or at a macro scale. So now we are talking about this powerful paradigm of location where we have several technologies ranging from satellite remote sensing to Internet of Things to BIM, GIS, GPS, and so on, bringing this rich, high precision location data to the various users. So now we talked about location. That is a location on the planet. Now let's think about a different aspect of this whole paradigm, which is objects. So at the end, when we talk about these smart initiatives, it's all about making human life better. If I summarize it, that's what we're striving to do, is about improving the human experience or human lives. So when we talk about that, one way of looking at this problem is you know the location, you can describe the location on the planet Earth. Let's put that aside, and now let's talk about objects. So immediately, as you know, there are two types of objects. We have static objects, and then we have dynamic objects. So static objects are something like this building. So the moment I know that this building is an object, the sheer size of this building gives me an idea that it's not a residential building. It's either commercial or industrial. And then the parking lot, which has some dynamic nature, even though it's static, the number of cars of this object actually starts giving you properties of the object. The reason that's important is if you start thinking about it, at the end, we want to understand these various objects that exist on the ground. And the static objects, for example, could be buildings, it could be roads, it could be a tree, it could be a forest, it could be a river. So now we're starting talking about what we call a digital globe, a living digital inventory of the planet. We are starting with an inventory that is static, which includes the buildings, streets, and so on. So when we talk about the static objects, you should be able to understand not only what that object is, but also what are the object properties. Like I said before, once I understand the object behavior based on its properties, I can also look for anomalies. For example, if this building, again, going back to this example, if the parking lot was empty for 365 days, that gives you an information that this particular building either is being rebuilt or is being abandoned or some other kind of information you can start deriving about a particular object. So, or another example would be an agricultural field. You know that that particular field will go through phases. Even though the field boundary can be defined as an object, the farmer might decide to only grow half the field. That's one way of looking at it. Or even if the farmer is growing the entire field, what is happening on that particular field is going to change based on the season or based on the crop growth season. So think about how do you create a living digital inventory of these static objects, because they become the foundation of understanding how do you take the data and now start looking at how do you describe these static properties, static objects that are existing on the planet. And then comes the very, very interesting part, which is the dynamic objects, us humans. So in countries like the United States, they have this social security system where they can identify every human, but that doesn't have any location associated with that. The best we could do is associate a human with an address. Now, thanks to the smartphones, humans are now carrying more than one mobile devices. So now there are companies, I wish like Pitney Bowes or XAD, PlaceIQ, these are the market intelligence companies that are trying to understand human behavior. It's scary that they actually know what you're trying to do. And I usually joke around, I don't know how many of you saw the movie Kumar and Harold go to White Castle. I come from Colorado, so that has a whole different meaning since we approved marijuana in our state. But the whole idea is that now you can actually take one or two individuals and you can start understanding their behavior. And the behavior can come from smartphones or the cars they're driving, because cars are now giving information that I leave my house around 8 o'clock in the morning, get to my Westminster office in Colorado in 25 minutes. This particular information is being garnered by all these market intelligence companies, so we are no longer talking about location data. We are now talking about location intelligence or location information, however you see it. So when Miladin talks about what it should be, I think there are companies already starting to look at individuals and saying, how do I describe Kumar? So one of my passions is golfing. And this happened to me last week when I was going across a golf course. Apple phone was able to tell me that there is a golf course nearby. So they're now trying to understand how these humans, based on their smartphones, based on their addresses, trying to define the patterns on how we actually behave in the real world. So at the end, we're still talking about technologies. This is where I want to bring up a quote from Steve Jobs. I'm not going to say the actual quote, but when he was asked, why did you release iPad? Why did you design iPad? And strangely enough, the answer was, iPad was not designed to be a technological advancement from Apple. Apple, or Steve Jobs, designed iPad not to make it faster, cheaper, better than a desktop. That was not the focus. It was all about consumer experience. So when Miladin started talking about user experience, this is about taking that rich information, rich data, and making it accessible so that the technology is no longer a focus anymore. So when I see all of the discussions we have, we are actually in what I call, we moved from a data-poor paradigm to data-rich paradigm. Very similar to Miladin, he's a surveyor, I'm a civil engineer. 20 years ago, if I were asked to do a 3D model of this area, all I had was a laser equipment. I would have probably taken 100 measurements in a day, or maybe 10,000 measurements over 20 days, and started extrapolating small data sets into a larger area, which was not a true representation. Now we have technologies that can actually collect 1 billion points of this whole entire room within an hour. So we have actually moved from what I call the data poor to data rich paradigm, so we can actually start solving old problems much more efficiently than we could do before. The example I give is if you're a surveyor and if you're into civil engineering, some of the best maps of India were made by the British in the 1800s. It was done using chains. Thank God I actually started using laser when I did my civil engineering. They actually had chains where they basically did the trigonometry and did this surveying of the entire India. It took them 60 years, and then the rumor is 600 people died of malaria. So we are in a new paradigm where, using satellite imagery, for example, we were able to create a 0.5 meter mosaic of entire India, almost cloud-free, in actually 2 weeks at 50 centimeter resolution. And where we are headed is we're going to start at least replenishing the cities where there's most interest at 30 centimeter resolution. Then when you look at these UAVs and other technologies, now you have this abundance of location information that can actually be so precise, you can start addressing some of the smart initiatives. They can be GeoSmart India, or they can be GeoSmart cities within India. So now, we talked about this, and the reason I brought up that I'm a civil engineer is the next aspect is, again, going back to Steve Jobs' terminology is, as a geospatial industry, we need to take technology out of focus. We need to talk about consumer experience. So I'm going to use a terminology, and this is biased primarily because of my educational background. I call it 21st century cartography. Cartography is the profession of making maps. It doesn't need to be the profession of making maps. It can be the profession of visualizing this rich content, like some of the examples Miladin was showing is the maps have changed, they're dynamic. How do you represent the roads on a map? They have changed as well. the Googles, the Apples, and the Microsoft have changed the cartographic standards for 21st century. So we need to embrace that. Also, knowing that it's about maps anymore, because the moment you create a map, it's already outdated. Now we are talking about a visual representation, so the end consumer, it could be a common person, can look at something and get the information they're looking for. In this case, when you're talking about GeoSmart India, this information need to be consumed. The user experience need to be designed in such a way that it's no longer about the geospatial technologies or the data that's behind it. It's about the outcomes you're trying to support using these GeoSmart initiatives. So based on these three concepts, again, there is location. There are several technologies providing location. Then you have this concept of objects, static objects, dynamic objects. And then finally, this whole concept of 21st century cartography, which is primarily visualization of the information. I want to share with you what DigitalGlobe is working on to meet some of these aspects. In terms of location, as I mentioned before, we have been collecting sub-meter resolution imagery since 2000. So one of the things we embarked on now 2 years ago was to create an accurate mosaic of the entire globe, and we will be finishing that by middle of this year. And this would be the most comprehensive, accurate, consistent data set that has been ever produced. The second thing we are doing is we actually have created a program called Plus Metro. We have selected 2,600 metros, which we'll be updating annually. And then going back to the discussion about objects, we are actually partnering with several companies that were actually around here to start creating this living digital inventory. We have a program, we call it Engage Africa, and this initiative, we are working with several nonprofit organizations like Bill and Melinda Gates Foundation. We are actually answering three fundamental questions. We are not talking about technologies. We are trying to answer three fundamental questions about where do people live, how many people live there, and how do you get to them. And geospatial technologies are providing this precision location and finer details that we are leveraging from our imagery as well as other sources to create these rich data sets to solve real outcomes. In this case, with Bill and Melinda Gates Foundation, we are working with them to eradicate polio in the entire continent of Africa. So when going back to this topic of geosmart cities, for me, location as well as these objects are foundational technologies to make it happen. My recommendation would be is, as an industry, let's think about what is the user experience and what are the outcomes we want to support. Again, going back to my philosophy that at the end, we are here to make human lives better. So let's use these geospatial technologies with other set of technologies like clouds and so on, so that we can take these geosmart initiatives, at the end, make this world a better place. Thank you.